Unit 1, the alphabet and grammar of geometry. Lesson 1.4, algebra review. Don't forget the date, time, location, as well as a parent-guardian sign-off. Focused attention equals faster and more efficient work. Please don't multitask. Turn off all distractions. For this lesson, we're going to be backtracking and covering some very, very key simplistic algebra skills. These skills, they're only a simple review. If any of these skills do not seem automatic and are more cumbersome to you, it is important you make extra time in tutoring to do more examples and more practice. So the skills we're going to be working with is computational math with fractions, solving with variables, adding, subtracting, multiplying, and dividing, radicals, which is another name for square roots. Very important, folks. If your prior math class did not thoroughly introduce exponents and square roots, in other words, you did not thoroughly explore things like this. When we do go over the radical section, if it's completely new to you, you need to make extra time for tutoring and come in and see me. You have a giant gaping hole in your Algebra 1 class if what I go over today is not a review. If it's the first time you see it, come in for tutoring, please. First thing we're going to deal with is longhand computational math. No calculators. Very important you see the difference when you're working with fractions. When you have fractions on the same side of the equal sign versus two other sides. If you have two fractions on the same side of the equal sign with nothing but a multiplication sign, you can cancel if they're on the same side of the equal sign. What I do is I imagine you have two different backyards here, a left backyard and a right backyard, and you have a fence, meaning the equal sign between them. If you are in your own backyard, you can rearrange the furniture as much as you want. So because there's a multiplication sign, I can do this. 4 goes into 12 3 times. 3 goes into 6 twice. 3 goes into 9 3 times. Then you multiply like this straight across, and you're going to end up with 3 over 6 reduces to 1/2. Now over here, you notice we're on two opposite sides of the equal sign. So, and you have your neighbor's fence. You cannot go across the neighbor's fence and take stuff away from your neighbor. Watch what I'm doing. Ready? Oh, that's 3 goes in there 3 times, 3 goes into 4 times. What I just did was wrong because there's an equal sign between the fractions. You cannot go over a neighbor's fence and take stuff away. Instead, if there is an equal sign between the fractions, you multiply. Do not be reaching for a calculator to do 12 times 9. The key to multiplying is not multiplying. It's factoring. The key to multiplying is not multiplying. It's factoring. The key to multiplying is not multiplying. It's factoring. So notice, I didn't actually multiply 12 times 9 here. Why? Because it's going to be easier if I just factor. So I want x by itself. I'm going to divide by 4. Then I'm going to circle the 4 and the 12 because they can factor out. 4 goes into 12 3 times. There's nothing else to factor. So 3 times 9, 27 equals x. The key to multiplying is not multiplying. It's factoring. Recapping, dividing fractions. Dividing fractions is the same thing as multiplying by the inverse. So 5/9 divided by 10/12 is the same thing as multiplying by the inverse. Now, because we're on the same side of the equal sign, you can go ahead and factor stuff out. Five goes into 10 twice, 3 goes into 9 3 times, and 12 4 times. And you simply multiply straight across once you factor. That's 4 over 6, just 2/3. Adding and subtracting fractions. When you have alike denominators, you simply add the numerators. But obviously, with 7 and 2 there, you first need to get what's called the lowest common denominator, the LCD. So you ask yourself, 7 and 2 go into what number, the smallest number possible? Well, neither 2 or 7 go into anything else, but the smallest number possible is 14. Watch what I do here. Put a little 14 here. Now I'm going to go in and out. So 7 goes into 14 twice. 2 times 5 is 10, so I translate this into 10 over 14. Put a little baby 14 here. Two goes into 14 7 times. 7 times 1 is 7. Excuse me, that's a plus sign there. Then you simply multiply not multiply, you're going to add the numerators, and we get 17 over 14. And that is our final answer. We ask ourselves, what does 4 and 6 both go into? The lowest common denominator, and that is 12. Put a little baby 12 there next to both of them. Get really close so this is easy to see. 4 goes into 12 3 times. I put a little baby 3 there. 3 times 3 is 9, so 3/4 translates into 9 over 12. 6 goes into 12 twice. 2 times 4, that's 8. Bring down the minus sign. Now you just go straight across. So on this page, we talked about the difference between cross-multiplying and versus cross-canceling. This page, we dealt with dividing by fractions and working with LCDs. This page, you are going to do and this page completely on your own, work in pencil, and then you're going to correct in red pen. Pause the video. Welcome back. With a red pen in hand, let's recap what you did here. If it's on the same side of the equal sign, you can cancel. That's 4, 5. So your answer here should have been 4/5. This one, you cannot cross cancel. We multiply. Because you're going across an equal sign. Why didn't I do 3 times 36 and multiply it out? Because the key to multiplying is not multiplying. It's factoring. If you used a calculator there, you cheated. I do not want you using calculators for any of this. Key to multiplying is not multiplying. It's factoring. I want to get rid of the 12, so I'm going to go like this. 12 goes into 36 3 times. 3 times 3 is 9. Do not want you using a calculator on any of this. These guys, dividing by that fraction is the same thing as multiplying by its reciprocal. That's the reciprocal. Now, because you're on the same side of the equal sign, it is okay to cancel stuff out when you're just multiplying. I end up with 2 over 3 times 8. I can take that down one more, and I end up with 1/12. If you're getting any of these wrong, I want you to write a note in the margin. What do you need to remember next time? Adding and subtracting. We find that our LCD there is 18. Little baby 18 there. That's a minus sign. I bring down my minus sign. Ended up with 10 minus 9. That's 1 over 18. So that is dealing with a fraction. Solving for basic variables. Key things you want to watch out for. So when working with equations, of course, we're going to follow the general rule of PEMDAS. But a couple things I want you to always do in this class. One, when you distribute, I want you to physically circle what you're distributing. Always physically circle what you are distributing. And I'd like you to draw very carefully the distributive lines. I get feedback from our calculus teacher that we have very, very intelligent students in calculus that make incredibly simplistic mistakes on 3-page calculus problems because they forget to do something so simple as distributing to the second term properly. By physically drawing those distributive lines, that will lower your error rate. Circle distributive lines. Let's write our second line here. Then I do what's called physical collect, some sort of notation that helps your brain distinguish between things with variables and things without. I tend to underline everything that has a variable and double underline my non-variables. Collect before you cancel. Do not start canceling across the equal sign until you fully collect everything that you can collect. You understand when I mean collect, that negative k plus 8k becomes 7k. Negative 6 and positive 3 becomes negative 3. Then, of course, we have two 5k's here, so that's 10k. That's collect. After you collect, then you can start canceling on either side. You want to get variables to one side and numbers to the opposite side. So I'm going to take the number to the right. I'm going to take the variable to the left. You should have numbers on one side, variables on the other side. Then you isolate your variable. What's really nice here, it is very easy to check your work just by taking that variable. If you were a test, if this was a test, I would actually do this and plug that -1 wherever you see it, and both sides will balance out. So that's one, solving for a variable. Next thing you have to be able to do is isolate a variable. You're not exactly solving, you're isolating. We use this when you have multiple variables. First, I'd just like you to rewrite this equation. Now, our goal is to isolate the variable y. I'm going to give you a funny scenario. I like to think of funny stories. This is not meant to be disrespectful or stereotypical of anyone. It's just a funny story to help you remember. Okay, folks? All right, so I am visualizing this as if you have a variable with a number, that's a date. Okay, so we have girl X and date boy 4, and you have another couple here, guy Y with girl 12. There's another date. And then you have a single person over here. Think of it like a party, a single person in the other room. Okay? Now, we're going to isolate Y. Let's say Y gets an attitude. I don't like this party. The music is terrible. The food is yucky. I'd rather do something else. You think, who's going to leave the room first? Now, the date's not going to leave the room first because they just got there. And if you're a girl and you're out for an evening, you've spent all this time getting ready. So girl 12 is going to try to stay. Oh, honey, please, let's stay. I got my hair done. I just saw my friends. So girl 12 is going to try to stay. Instead, the other couple over here, they're seeing this Y guy over here have a meltdown, and they're like, we're getting out of here. We're not going to watch a couple meltdown. So this couple cancels and goes to the other room. You'll see why I brought the x first. Now, very important, that 4x did not impact that 36 because that's a non-variable and that has a variable. Okay? Now, Guy Y still has an attitude, so finally the date has figured out this dude is a jerk. He's not fun to be with. So you think out of add, subtract, multiply, divide, what's the most painful of those operations if you are a couple and a broken heart is closest to divide? So we're going to divide out that negative 12. Warning, guys, this is almost actually true. If you break a girl's heart, she's going to go next door and she's going to gossip to every single person in the other room and explain to everybody how much a jerk that date was. Okay, do you see my analogy here, students? Gossip to everyone. So when we divide out that 12, we take that 12 and we divide it out to every individual term each term. Okay, I do not want to see this 4x plus 36 divided by negative 12. I do not want to see it like that. That is notation. It's a shortcut, but students make too many mistakes. They forget to divide out both terms. So I do not want to see it like this. I want that negative 12 to gossip to each term individually. Now, the y is finally by himself. And you just kind of clean up. Double negative makes a positive. 4 goes into 12 3 times. Positive divided by a negative, that's minus. 12 goes into 36 3 times. Your final version, y now by himself, everyone else in the other room, y equals 1/3 x minus 3. I think you see why now. Why I brought that x first. You write that there. Now right underneath, I'd like you to write this. Reason I put the x first, y equals 1/3 x minus 3, because now it's in y equals mx plus b form, which is the slope-intercept equation of a line. Solving for a variable, isolating a variable. I'd like you to do this page on your own, work in pencil. Pause the video. Welcome back. Let's see how you did here. Let's check your work. Some of you might have got stuck here. You're wondering, -7 times what is 0? Guess what, folks? The only number that is a true statement there is x equals 0. X equals 0. The only thing that makes that a true statement is if x equals 0. And 0 is a number, folks. The Mayans figured that out. Yay, Mayans. Down here, isolating the y. So remember, the storyline is guy Y has an attitude. Girl 9, she's going to try to stay if she can. So the other couple leaves first. Turns out Guy Y is just going to keep with his bad attitude, so the date finally leaves, breaks the heart by dividing. She's going to come over here and gossip to everyone. Y equals 2/3 x minus 3. So what have we done so far? We have worked with fractions. We have worked with variables, and now we're going to work with radicals, also known as square roots. Students, once again, I am treating square roots as if you've seen them before. If you have honestly not worked with radicals like ever before, and there's a few Common Core classes that students have taken where you did not get to the point where you talked about exponents of squares and square roots. You need to make extra time to come and see me in tutoring so that I can go more in depth with you, because I'm treating this as a review. If it's not a review, you need to take at least 45 minutes of your time for extra tutoring so I can backtrack and get you back to square one. First thing you need to learn how to do with radicals is simply called simplifying a radical. I use a method, again, I like hokey storylines, so I'm going to call it going out on a date. You start by factoring. So 108, I'm going to choose a number that I can factor. Generally, if it's an even number, I just use 2 as far as I can all the way down. So it's 2 and 54. Then you keep going. What goes into 54? I know 6 and 9 goes into 54. And you want to get it down to all primes. You look at the leaves. I like you to circle the leaves. Circle the leaves. These are what I call leaves. I want you to ignore the branches. 54 is a branch. Cross it out. 9 is a branch. Cross it out. 6 is a branch. Cross it out. Do you understand my difference between leaves and branches here? Then you look for what I call dates, doubles. We have 3 and a 2. Storyline is this: if you have a date, you get to go out, but when you go out, the word couple is singular. We say, oh, there goes a cute couple. So if I bring out a date of 3s, only 1 3 comes out. A date of 2s, only a 2 comes out. I'd like you to box this 3. That 3 has no date among the prime numbers. Stays home, orders Chinese. Your final answer. These guys out here multiply. So root 108 simplifies to 6 root 3. There are several different methods to doing this. If you learned another way to do this, I'll give you an example. Use whatever method works for you. A few people learned what's called upside down division. It looks like this, 108. And you simply go backwards divide. I'm going to divide by 2, and I get 54. And I divide by 2 again, and you get 27. And I divide by 3, and I get 9. So I divide by 3 until I get 3. Again, your goal is to get all primes. That's called upside down division. Same concept. Every date comes out. Lonely here stays home, orders pizza. 6 root 3. So whatever method you learned to do this, go ahead and use it. I'm not going to try to fix what's not broken if you know how to do this. Let's do another example over here. I'm going to factor 54. 2, 27. Looking for dates. I have one pair of threes. I circle it. I bring it out. They come out as a single couple. So 5 root 54, those are going to multiply, is going to be 15 root 6. I'd like you to take what you just learned, and I'd like you to factor and simplify both of these radicals. Pause the video, do this on your own. Welcome back. Let's see how you did with the 63. I'm going to go ahead and use the backwards division style just for giggles here. And I know that 9, 7 goes in there 9 times. So I have a date. That's going to be 3 root 7. Over here, I'm going to use the factor tree. I'm looking only at the leaves, not looking at the branches. Those branch, 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 branch. I cross them out. I look at my leaves. I have one pair of 2s, another pair of 2s, a 3 and a 5. So I have 2 times 2 and 15. You should have gotten 4 root 15. If you did these correctly, give yourself a giant smiley face. If you did not, take a moment and figure out where did you drop the ball and write yourself a note so you don't forget. So that's called simplifying a radical. You also need to be able to add and subtract radicals, multiply radicals, and divide radicals. Add and subtract radicals. I'd like you to look at this variable expression. I'd like you to go ahead and simplify as far as you can. Watch the colors here. I'm going to use red. I'm going to collect my Z's. My X's. My Y's. Notice I'm using what's called physical notation. I'm also using colors. It's a negative sign, so watch out for that. Okay, that's as far as I can go there in simplifying with those variables. Now watch very, very carefully. Radicals follow the exact same rules as variables. I'm going to do this very slowly. So if I have negative 7z plus, technically there is a 1z here, plus 1z, I get negative 6z. Look down here, root 2, root 2. Negative 7 root 2 plus root 2, technically there's a 1 in front of that. We're going to collect these just like the variables. I'd like you to underline them. Negative 7 root 2 plus 1 root 2 is 6 root 2. Just like when you collected the z's, the physical z does not change. This radical, when you're adding, does not change. Root 5, 3 root 5 minus 2 root 5. Notice the radical did not change, just like the variable did not change when you add or subtract. Last, triple underline, 8 root 3 minus 5 root 3. Moral of the story is radicals add and subtract following the exact same rules as variables. Okay, now the only other thing you have to watch out for is sometimes you have to simplify the radicals before you can add or subtract. So notice the radicals here, none of them you can simplify farther. I chose this all prime numbers just to simplify the process. Down here, notice that's not prime, that's not prime, that's not prime. If it's not prime, you first have to simplify before you can add or subtract. So if it's not prime, we're going to factor all of them. Watch. Why didn't I touch that 5? Because it's prime. When I factor 5, I get a 1 and a 5. There's no other components. Now we're going to simplify. So for this one, that root 2, that double 2 is going to come out right there, and it's going to change to minus 2 root 5. The double 3's are going to come out. Do a little arrow, make that a little baby 3 there. That's going to be minus, there's a 3 already, so that's minus 9 root 2 minus 3 root 5. This last one, double 3's come out, little 3 there times the 2, that's a plus sign. Watch out for plus and minus signs. 6 root 5. Now that your radicals are all down to primes, you want to collect like radicals. So I have a root 5, root 5, root 5. I'm going to collect. It's negative 2 minus 3. That's minus 5 plus 6. All of those collect to 1 root 5 minus 9 root 2. And that is as far as you can go. You cannot do anything else with that. Just like if I had 1x minus 9y, that's as far as you could go. You try. I'd like you to both simplify and then add and subtract these radicals. Simplify, add and subtract these radicals. Ready? Pause. Welcome back. Let's see how you did. So there's nothing to clean up there, so that's going to be negative 2 root 5. Now we're going to collect like radicals. I have root 5 and root 5. Negative 2, positive 4. That's going to be positive 2 root 5. Root 2. Negative 9 plus 3. That's negative 6. Root 2. And you are done. If you did this correct, give yourself a giant star or a smiley like you are just so brilliant and wonderful. If you didn't get this correct, I expect to see some sort of notation. What are you going to remember next time? A little note so you don't forget. Okay, so we have simplified radicals. We've added and subtracted radicals. Now we're going to multiply radicals. Outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. Think outie and innie like belly button. This is not technical terms. You'll understand what I mean in a moment. Outies, innies, simplify. You use this when you're both multiplying and dividing radicals. Ready? I suggest get your quad pen. Outies, draw an arrow connecting the numbers on the outside. That's why I call them outies. 3 times 7, 21. Innies. I have 3 times 6. I'm going to prime factor this 6. That's 3 times 3 times 2. What did I just do there? I factored out the 6 to prime factoring as a shortcut. And you take your doubles. They come out as a single date, outies, innies, simplify. No, you may not use a calculator for 3 times 21, folks. Final answer, 63 root 2. Outies, innies, simplify. Do this one on your own. Pause the video. Welcome back. Let's see how you did. Outies, innies, 15, that's prime factoring. Simplify. You should have gotten 70 root 3. Outies, innies, simplify. That's multiplying radicals. Dividing radicals, you follow the same process. Outies, innies, simplify. Okay, step 1. When we divide radicals, first, we're going to take our outies and see if we can't reduce them first, which in this case we can. 5 goes in there 4 times, so that's a 4 and a 1 above. That's outies. Now we check our innies, 12 and 18. They can also simplify, right? 3 goes in there 4 times. 3 goes in there 6 times. 2 goes in there twice. 2 goes in there 3 times. Okay, now we're going to bring the cleanup version down here. So I have 1 root 2 over 4 root 3. Outies, innies. What you need to simplify is you cannot leave a radical in the denominator. No radicals in those basements. No evil radicals. You don't want them in your basement. They're going to come up and get you. You got to get rid of those evil radicals in your basement. That's one of my hokey storylines. The way you do that is you're going to multiply top and bottom by the same radical. Watch what happens. Root 2 and root 3 become root 6. Root 3 times root 3 technically is root 9, which just becomes a plain 3. So down below, you're going to have 4 times 3. Final answer, root 6 over root 12. You cannot simplify any further. Why? Because root 6 is an innie, and 12 is an outie. Innies and outies do not communicate with each other. Okay, so this cannot be root 1 over 2. What I just did was wrong. Innies and outies do not communicate with each other, so you cannot go any farther. Your correct answer there is root 6 over 12. This I want you to try on your own. Innies, outies, simplify. Pause the video. Welcome back. Let's see how you did. Our outies first reduced. That's a 1 and a 7. Our innies reduce. Let's see. 4 goes in there 8 times. 4 goes in there 3 times. Let's bring the cleaned up version. 1 root 8 over 7 root 3. Got to get rid of that root 3. We're going to multiply top and bottom by root 3. This becomes square root of 24. And this is going to be 7. Root 3 times root 3 technically is root 9, which just becomes 3. Root 24 over 21. Now, if you stop there, you would get partial credit on a test. But you need to recognize that root 24 can be simplified. I'm going to prime factor it. 2 times 2 is 4, times 2 again is 8, times 3 is 24. That's prime factored 24 over 21. Then you bring out your dates, which is a pair of 2's. Final answer, 2 root 6 over 21. The outies don't simplify. The innies and outies don't talk to each other. Your final answer, 2 root 6 over 21. If you got it correct, big star, smiley. If you didn't correct, I expect to see a little note. What are you going to remember next time? I know this was longer here, but these 2 minutes are still absolutely critical. Take 2 minutes and look at each page of your notes and verbally summarize, take about 30 seconds, each section. What was the main thing you learned? Go.